confidence intervals can be a little tricky when you get started. So let's do some simulations. There's this website here that we can use to run different simulations. We've got a mean of 0.5 and sigma, so standard deviation of 10. Let's run one example. So we ran this one time, and you can see we've got 100 things in their distribution. It kind of follows this pattern. It does include the true mean. So the true mean is 0.5, and a little green line crosses over that. So it is included in our 95% confidence interval. What happens if we change this to 99%? You see how wide the interval is here. We recalculate, it got wider. So a 99% confidence interval made it bigger. What if we drop it down to 50%? It got much narrower. So as the confidence level gets higher, then the width of the interval gets bigger. So as the confidence level increases, the width increases. So we ran this one time, and this was our outcome. We got a mean of negative 0.39 right here. What happens if we run it 10 times? All right, so we ran it 10 times, and you can see these look like they all cross the mean. Great. The true mean is 0.5, and our mean from this data is getting closer to 0.5. Okay, we ran it 10 times. Now let's run it 100 times. So we ran this 100 times, and this one here in red is the only one that does not contain the true mean. Since our confidence level is 95%, we'd actually expect 5 of these to not be here. So we're actually running higher than expected. We'll run this 1,000 times. You can see now we have more that are these trials that did not contain the true mean. These are random samples that you could do that did not include the true population mean. Right? So we are wrong about 5% of the time. You can see here it is accurate about 95% of the time. Right? So about 5% of the time it's not actually capturing the true mean. And you can see our distribution here is starting to look more normal. Let's add another 0 here and run it again. Now our distribution is looking much more like a normal bell curve. And you can see out of 10,000 runs, 9,515 included the true mean. So that's exactly what we'd expect. What happens if we change this to 99? Then 99% includes the true mean because the width got bigger, the interval. Let's change this back to 95. Add another 0 here. So now doing this, let's add 100,000 times. We've got almost a perfect distribution here. The last sample that was run looked like this, but when you aggregate them all together, you get this kind of shape. 0.5 is actually odd. Let's change this to 0. And there we go. Now it's centered on 0. That's nicer. So the true, all these tests, all these simulated experiments, they were right 95% of the time. They included our true mean of 0. That's exactly what we'd expect. All right? So we can change this to t and see how that performs. Let's go back to 1. We'll do standard deviation of 1 as well. So we got that one right. Out of 10, we have 1 that wasn't captured. So that one was wrong. If we run this 20 times, we'd expect 1 to be off. We have 3 off. So it's much lower than we would have expected.